All right. So, what we're going to work on now are we're going to work on some word problems. So, if you want to get your instruction book out and turn to page 120 in your instruction book, we're going to be working on some independent practice. So, this first problem says a person blinks about 16 times per minute. About how many times does a person blink in 3 hours? Right? Well, we need to go ahead and first multiply 16 times 3, right? So 16 times 3, all right? I am multiplying 3 times 6 and 3 times 10, and then I'm adding those together. So 3 times 6 is 18, 3 times 10 is 30. I add them together and I get 48. Well, then I have to multiply 48 by 60. Okay, because that's how many times per minute in the 3 hours. And I have to multiply it by 60 minutes because this is for hours. We got to make them both minutes. Okay. Well, so what I'm going to do is I'm going to use that area model to solve this problem. You could use whichever method you would like. I am just going to emphasize the area model. Okay, so we have 48, 40 plus 8, and 60 plus 0. So then I'm going to multiply 40 times 60. Well, remember, if we hold the zeros, that's 6 times 4 is 24. Add two zeros, it's 2,400. 40 times 0 is 0. 8 times 0 is 0. 8 times 60, again, hold that 0. 8 times 6 is 48. Add a 0, it's 480. 2,400 plus 480 gives me 2,880. So, which of these answers match my answer? It is D. D. Okay. So, if you wanted to do it, if you decided to do it with the partial products, you would see that 8 times 0 is 0. 8 times 6 is 48. 8 times 60, 8 times 60 is 480. Okay. 40 times 0 is 0. And 40 times 60 is 2,400. Add those together, get 2,880. Same as here. Okay. Or you could have done it the standard algorithm and still gotten that same answer. All right, let's look at number 2. Mr. Larson is planning a pizza party for 273 people. He plans on 3 slices of pizza for each person. How many slices of pizza is this in all? Okay, so I need to find the total number of slices of pizza. Well, if that's 3 slices per person, and I have 273 people, I have to multiply 273 times 3. Now, there's multiple ways you could do this. We could do that area model again. Okay, now I know we worked with 4-digit by 1-digit numbers and 2-digit by 2-digit, but 1-digit by 3-digit is very similar to 4-digit by 1-digit. Okay, you just have 3 digits instead of 4. So when you do that area model, instead of the 4 boxes, you just need 3, right? Because you need to make sure that's how many boxes you have is how many digits one of the numbers has. The other number has 1 digit, so it only needs 1 box. Okay? So we'll do expanded form 200 plus 70 plus 3, right? 200 times 3 is 600. 3 times 70 is 210. 3 times 3 is 9. Add those together, 600 plus 210 plus 9, and you get 819. Is that one of my choices? Absolutely. Again, you could have done it the standard way. Could have gone 3 times 3 is 9. Okay, 3 times 7 is 21. So put down my 1, carry my 2. 3 times 2 is 6 plus 2 is 8. Or you could have done the partial products way, okay, which is very similar to this, and you would have gotten the same answer. All right. So now we're going to move on to this problem. Number 3. So number 3 says, can the expression be used to solve 29 times 14? We got to choose yes or no for each expression. Okay, so 29 times 14. All right. Well, I would go ahead and solve 29 times 14 using using those 3 methods. So then I can see if any of these match the way I did that. Okay? So I'm going to do that area model. Okay? Right? Remember I got to have 2 and 2. It's a 2 by 2. So 20 plus 9 and 10 plus 4. Okay? So I'm going to do 10 times 20, which gives me 200. Okay, I'm going to do 10 times 9, which gives me 90. I'm going to do 4 times 20, which gives me 80. And I'm going to do 4 times 9, which gives me 36. Add those together, 200 plus 80 plus 90 plus 36. Okay, and you will get 406, I believe. Let me see. Yeah, 406. Let's just double check. 280, 90, that's 170, 370, 30, 406. Yep, 406. Okay. All right. Well, then I could do this way, do 29 times 14. So I would do 4 times 9. Okay, 4 times 9 is 36. 4 times 2 is 8, plus 3, 9, 10, 11. Put a 0. 1 times 9 is 9. 1 times 2 is 2. Okay, and again, I would get 406. Now, look what I did. I did 4 times 9, right? And then I added 1 times 9. Okay. And then I did, or 10 times 9, sorry. Then I did 4 times 20 plus 4 times 9. Okay. So I added all of those up together. All right, well, let's go ahead and look and see these and see if we got anything so far. So 9 times 4. Did I do a 9 times 4? I sure did. Did I do a 20 times 4? Yep, 20 times 4. Did I do 9 times 1? No, I did not. 20 times 1? No, I did not. That total, you cannot solve that, would not be the answer. So, no. 14 times 9 plus 14 times 20. Well, I could do that. Yes, because I could do 20 plus 9 is 29 in expanded form, right? And I just multiply that by 14. That's 20 times 14 plus 14 times 9. So, yes, I could. See, 9 times 4, 20 times 4, 9 times 10, and 20 times 10. No, I don't need to do 20 times 10. Do I? I do. 10 times 20, 200. Forgot that in there. So 10 times 20. So, yes, I would say yes. 29 times 4 and 29 times 10. That's the same as doing it the opposite way. If you had 10 plus 4, which is 14, you multiply that by 29. 29 times 20 and 29 times 4. So you'd be no, yes, yes, yes. Okay. So this was a really difficult problem. Okay. Because you have to see what you multiplied number wise by. Okay. Or what you could do is just solve the answer and then look through here and see if you multiply those together and you add them all up, does that answer match that answer? That's another way you could go through and solve it. Okay. So that was number 3. All right, number 4. Number 4. So which models could represent the solution to the problem 45 times 15? Circle the letter for all that apply. All right, well, let's look at letter A. So it looks like we have a grid. Now, does this look kind of similar to what we did before? Look, if we drew a line where these were, okay, you would see that it looks just like that area model, right? We have the 40 plus the 5, and then the 10 plus the 5 here for 15 and 45. But this is just showing you how many squares are 10 times 40. All right. And then same here, 40 times 5, that's how many squares is that? 5 times 5 is here, 5 times 10, that's how many squares. So it's showing squares, just not numbers. So I would go ahead and circle that, okay? Because we got to find the models that could represent the solution. So look at letter B. It looks like this is going up by 5s or 15, by 15. So 15, that's 1, 2, 3. Well, that's only 15 3 times. Does that have anything to do with 45 times 15? No, it shows you 15 times 3 is 45, but it doesn't tell you what 15 times 45 is. So no, not that answer. What about this? 4 times 1 plus 4 times 5 plus 5 times 1 plus 5 times 5. Well, let's draw it out, okay? If I do that, I'm doing 5 times 5. Okay, that's there. All right, and then I do 5 times 40. Nope, see, it's not 4 times 5. It's 5 times 40. Remember, it's the value of that digit. And then 1 times 5, but I'm doing 10 times 5. Nope. And then 10 times 40. Nope. So that's not right. So I got that one correct, but I still needed to make sure that I'm having those tens and stuff. Okay. So that one's incorrect. What about 4 times 1 and 5 times 5? 4 times 1 and 5 times 5. Can I just go straight down? 5 times 5 is 25. 4 times 1 is 4. And that's 29. That does not work. Okay. That is not, you cannot just go straight up and down. You have to go diagonal. All right. So it's not D. Let's find out E. All right. If I have 0 and I go up to 45 plus 45, and that looks like it's another 45. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Is that showing me that I have 45 15 times? Absolutely. Does that show 45 15 times? Yep. So I would definitely circle that. All right. So now let's go ahead to number 5. Number 5. Okay. Number 5 says Mo had 14 tutoring sessions. Each session was 35 minutes long. How many minutes did Mo spend in the 14 sessions combined? So it gave us 3 numbers, but we only need to focus on these two, 14 and 35. They want to know how many combined, what's the total combined? Okay, I'm not going to add, I have to multiply because that's 14 sessions and each was 35 minutes. So that's 35 minutes times 14 sessions. Okay, so this is where you're going to solve it. You're going to do 35 times 14. Go ahead, pause the video here and try to solve number 5 on your own. Multiply 35 times 14. You can use any method that we've gone over. Okay. So if you want this time, I'm going to go through the partial products model. Okay. So 35 times 14. So I'm going to do 4 times 5 is 20. Make sure I line up my place values. And then 4 times 30 is 120. Okay. Well, then I've got to see what's 10 times 5. See, I'm done with the 4. 10 times 5 is 50. And 10 times 30 is 300. So now I'm going to add all those together. I get 0, 5, 6, 7, 8, 9, 490. So I have 490 minutes in each 14 sessions. Okay, total. It's 490 minutes in the 14 sessions total, right? And you could have done that area model, okay? So you could have done the area model and you would have gotten 30 plus 5 and 10 plus 4. So you would have gotten 300 plus 50. You would have gotten 120 plus 20. But, and then you would have added those together and gotten 490. But look at this. Look at these numbers. What do you notice is similar? 300, 120, 50, 20. 300, 120, 50, 20. You're just finding the value of each digit and adding them together. You could also have done the standard algorithm, okay? And that would have still gotten you that same answer, okay? It would have just gone 4 times 5 is 20, 4 times 3 is 12, plus 2 is 14. Put a 0 to hold that 4. 1 times 5 is 5. 1 times 3 is 3. Add that together, and you get 490. All right? So 490 minutes should have been your answer. All right, one last problem. Number 6. All right, number 6. So this looks like it's going to be a 4-digit by 1-digit number multiplication. So go ahead. It says fourth grade students held a recycling drive. During 1 week, they collected 1,238 water bottles each day. How many water bottles did the fourth graders collect that week? Hint, there are 7 days in 1 week. Okay, well, let's see. If they did 1,238 bottles each day during a week, and there are 7 days in a week, that's going to be 1,238 times 7 because that's 7 days. So go ahead and pause the video here and solve for this problem. Come back to see if your answer is correct. Uh, All right, so there are a few ways you could do this. Well, I'm going to go ahead and do that area model. Okay, so I'm going to do the area model. You separate it into 4 parts. It's 1,000 plus 200 plus 30 plus 8 times 7. That's 7,000. That's 1,400. That's 210. And then that's 56. Add those all up together and you'll get 8,666. Is that 7,000 plus 1,400 plus 210 plus 56? Yep, 8,666. Okay, so they collected a total of 8,666 water bottles. All right, so that was just some more practice in your practice problem. Now I want you to go ahead and complete the assignment on the next side.